Welcome to Khetz Tutorials, and in this video, I'll be covering question 48 from 1.1 exercises in James Stewart Calculus. So we're asked to sketch this, and as you can see, it's a sum of two piecewise functions, so let's deal with them separately. Absolute value of t is t when t is greater equal to 0, and negative t when t is less than 0. And the absolute value of t plus 1 is t plus 1 when t plus 1 greater equals to 0, or negative 1, negative t, so basically the negative of everything here, like this. That's what we have. If t plus 1 is less than 0. So now this will work out as follows. So t plus 1 greater equal to 0 would be t greater equal to minus 1. Just took that to the right hand side. And the same applies for t plus 1 less than 0. So this will be t less than negative 1. So you can replace these with the following: t greater equals minus 1, t less than minus 1. Alright, so now it's time to sketch, but before we sketch, we want to have the correct regions where we have these functions. All of these are straight lines, and we want to draw them in the correct regions of t. And these two functions are being added, so we have to find what the resultant function is. So to do that, we're going to combine these conditions. As you can see, the conditions are different. And if we had a number line at 0, we'd have t greater equal to 0, which is this one. Then we'd also have t less than 0, which is that. Then for t plus 1, we have t greater equal to minus 1. So minus 1 would be somewhere there. So we have that condition. And finally, t less than minus 1, which would look something like this. So you now have to make sure that we combine these functions according to the places where they overlap. So let's start on the left. So this condition, t less than minus 1, corresponds to this function. All right, and it overlaps with this part where we have t less than 0. So this section here, these two functions overlap. So we have t less than 0, this one, and t less than minus 1. So those are the ones we're going to add. So h of t is minus t, then minus 1, minus t. So we just added this and that. And to describe this region where we're adding these, as you can see, we have to start at minus 1. We can't start at 0 because this blue section is not there. So we have to start where they start overlapping. So they start overlapping at minus 1. So this condition is for t less than minus 1. All right, then we're going to look for some more sections where they overlap. So as you can see, this part from 0, which is left out, overlaps with the top blue arrow. That is when t is greater or equal to minus 1. So at that point there, between minus 1 and 0, these two overlap. So the function that corresponds with t less than 0 is minus t. Then the function which corresponds with t greater or equal to minus 1 is this one, t plus 1. So you're going to add those two. So in this section, you're going to add t to t plus 1, and the region is described by minus 1 less equal to t less 0. So this is the cutting point, or this is the point where they stop overlapping as far as this arrow is concerned. So you're basically looking for sections where your conditions overlap and you're going to group them like that. And the final one is to the right. So after that section, this whole section overlaps. So from 0 going to the right. And it starts at t greater or equal to 0. That's where you have t. And with the blue one, that function corresponds to this one. So let's quickly fix this one, which is between -1 and 0. So at the top, this one, which is t less than 0, the red arrow, is actually minus t. So you just have to correct that. This is minus t, so you're going to add this one to this one. So that yellow section there, minus t and t plus 1 overlap over there. Then finally, that t plus 1, this blue line here, now overlaps with this one, which is t. So the last section involves us adding this, and this section is defined by t greater or equal to 0. So from this point, going to the right. And these are three functions which you're supposed to sketch. So if you combine these, we're going to have minus 2t minus 1 for t less than minus 1. And we're going to have 1 here. So this is 1 minus t plus t is 1 between -1 and 0. And finally, we're going to have 2t plus 1 for t greater or equal to 0. So this is what we're supposed to sketch. These are the functions we're going to sketch. So now let's have our Cartesian plane. And this is the t-axis, and I guess you can call this y. So h of t is y. You can interpret it like that. And now let's start. So we have -1, which is an important point. Then we have 0, the origin. And these are the 2 points that will decide what we have at each point. So to the left of -1, we have a straight line with a gradient of -2 and a c of -1, which means it cuts, or it was supposed to cut, the y at -1. So we can also find its x-intercept, which is as follows. So -2t minus 1 equals 0. That's how you find the x-intercept. You assign a 0 to y. So you're going to have this. And your t should have been that. But if you look at this, it's somewhere there. And this function does not exist at that point because it only exists for t less than -1. But you can use that information to visualize where it's supposed to be. So at this point, your line should have crossed in this direction, going this way. But you should only draw it in this section from -1 going to the left. Right? Because it's t less than -1. Then between -1 and 0, you have a function of 1. So y equals to 1. So that is just a horizontal line that crosses, or that has a y value of 1. It's just this line between -1 and 0. This is -1, this is 0. So we've covered that. Then for t greater or equal to 0, we're going to have 2t plus 1, which is a straight line with a gradient of 2 and a c of 1. So as you can see, it cuts at 1, so that's still in check. And its x-intercept would have been this. So it would have been the same as the x-intercept of this one. And now, so it would have looked something like this, but you're only supposed to draw it from this point at 0 going to the right. So we've now drawn our full function based on these conditions. So we started by solving these absolute value equations and we came up with these conditions. Then we later found the points where these conditions overlap. So t greater than 0 overlaps with t greater equals to minus 1 at some point. And wherever they overlapped, that's where we added the 2. And the new condition was the starting point of the overlap going either to the left or right. And these are the arrows which you use for that. So the blue arrows correspond to t plus 1, and the red ones correspond to t at the top. And you just had to look for your blue condition here, which goes to the left, which is t less than minus 1. That overlaps with t less than 0. Right? So you're going to take the function at t less than 0, add it to that function at that point. That's exactly what we did here. Then the new condition is the start of the overlap, which is at minus 1. Then we moved on to the right between minus 1 and 0. The 2 also overlap, but now this t less than 0 overlaps with t greater or equal to minus 1, which is a different function. And at that point, we're expressing that by adding the 2. And we now have a condition which describes the portion where they overlap. So they overlap between minus 1 and 0. Then after 0, or to the right of 0, the same function, which is t plus 1, overlaps with this function. And that's what we finally have here, where t is added to t plus 1. And once again, the start of the overlap is at 0, so you're going to go to the right of 0. And the equal to was only included due to the conditions. So here we have t greater or equal to 0. And that's the starting point of this one. So we use that. And the same applies here. At minus 1, this one is included, so we also included it in the condition. Right? And finally, for t less than minus 1, this one is not included, as you can see. So that's why we did not have an equal to over there. So in the end, you're going to have these functions, and you just had to draw the straight lines which correspond to each section.